discuss motion, let us describe first what a frame of reference is. A frame of reference is a set of coordinates that describes the points relative to a body to which measurements can be made. That is where you perform your observation. In dynamics, it is the coordinate system with axes, so the x-axis and the y-axis. Consider a person on the ground and another person on a moving car. From the perspective or frame of reference of a person on the ground, the car is moving. However, from the perspective or frame of reference of a person inside the car, the person on the ground is moving because they are from different frames of reference. For today's ride, we will observe the motion of my motorcycle from the frame of reference of the satellite above using GPS and Google Maps. So we will draw a Cartesian coordinate system just like this one to represent our frame of reference. And we are going to describe the motion of my motorcycle with this frame of reference. Remember that we start our motion at 19 seconds. That is the time indicated in this map. So take note of that because that will be used later in our discussion. From the perspective or frame of reference of the satellite, I am moving relative to the ground because my position changes over time. How are we going to describe motion? First, let us differentiate distance and displacement. Distance refers to the total path taken between 2 points. So in the Google Map, it is from the origin to this point, and that is shown here one, and that is 200 meters. So the distance covered is 200 meters. On the other hand, displacement is the shortest path from the origin to this point. That is the red line on the map. So we can estimate that using the scale. Say that is 140 meters. So remember, that is just an estimation. We can also describe the direction of this displacement as discussed in the previous lesson. Remember, displacement has direction. This is a speedometer which measures the speed of my motorcycle, of course, including me. Nagsakay ko sa motorcycle. The reading of this speedometer gives us the instantaneous speed or the speed at a particular instant, at a particular point in time. This time, my instantaneous speed is 30 kilometers per hour. Convert that into the standard unit, and that is 8.3 meters per second. If we include the direction to which this motorcycle is moving, say it is moving south, that gives us the instantaneous velocity, which is, this time, this particular instant, 8.3 meters per second south. So that means instantaneous speed is the magnitude of our instantaneous velocity. Ang kaibahan lang nila, si velocity mayroong direction because it is a vector quantity. Okay? Now, if you notice, there is a difference with the reading on my speedometer and on the Google Map. Baka kasi malito kayo bakit magkakaiba yung reading ng speedo at saka ng Google Map. That is scale error. So kayo malian na ang ako ang speedo or ang GPS. Let us pause here to elaborate the concepts. What is the distance covered? That's the total path taken, which is this time 0.8 kilometers or 800 meters. Remember, two significant figures tayo. Dalawa yan. The zero there is significant. That is our estimate. How about the displacement? That is the shortest path from the point of origin up to this point. See that red line on the map? So we can estimate that using the scale. So let's say that our estimate is 310 meters. And we can also describe its direction. So what is the direction? South. We can also say 310 meters south. The instantaneous speed at this moment is 22 kilometers per hour or 6.1 meters per second, and that is shown in our speedometer. Now, the instantaneous velocity, however, is 22 kilometers per hour or 6.1 meters per second. And in what direction is it moving? It is moving to the west. So 6.1 meters per second going west. How about my average speed? Average speed is the total distance divided by the total time taken to cover that distance, which is 1 minute and 51 seconds or 111 seconds minus the 19 seconds, which is our initial time. Remember our initial time, 19 seconds. That means the time elapsed is 92 seconds. That means average speed is 800 meters divided by 92 seconds, which is 8.7 meters per second. Two significant figures. Or, we convert that into kilometers per hour, that is 31 kilometers per hour. Remember that it is different from the instantaneous speed. How about my average velocity? Average velocity is the total displacement divided by the total time. So that means 300 meters divided by 92 seconds. And that is 3.4 meters per second or 12 kilometers per hour going to the south. Nakuha? Okay, let's go. This time, let us assume that the reading on my speedometer is velocity and not speed to make our discussion easier to understand. If you notice, the reading on my speedometer is constantly changing. What is the rate of that change? That is what we call the acceleration or the rate of change in our velocity, which is given by the formula, the final velocity minus the initial velocity divided by the elapsed time. So our initial velocity is shown in the speedometer, which is 19 kilometers per hour, or we'll convert that to the standard unit, 5.3 meters per second. This time, the velocity is 44 kilometers per hour or 12 meters per second. That is our final velocity. So from 5.3 meters per second, it changes to 12 meters per second. And the time elapsed is 6.80 seconds. We will pause here and calculate its acceleration. Acceleration is equal to final velocity minus initial velocity divided by the time. So 12 meters per second minus 5.3 meters per second divided by 6.80 seconds. And that will give us 0.985 meters per second squared, or using the rules of significant figures, 1 meter per second squared. Remember the unit of acceleration? It is meter per second squared, or in some books, meter per second. They are just the same. So that means 1 meter per second squared means my velocity increases by 1 meters per second every second. So that means I am speeding up. Dapat no, velocity up kay velocity man. Char lang. Let's have another example. Let us calculate my acceleration. This time, the initial velocity is 34 kilometers per hour or 9.4 meters per second in standard units. Okay, let's go. The final velocity is 0 kilometers per hour or 0 meters per second. And the elapsed time is 13.40 seconds. So let us calculate its acceleration. Acceleration is equal to final velocity minus initial velocity divided by the time. That gives us negative 0.7048 meters per second squared, or negative 0.70 meters per second squared. Remember the rules of significant figures. And 0 meters per second is not significant ha, basig malipat mo ana. Take note of the acceleration. It is a negative acceleration. Kanina, positive yung acceleration natin. Ngayon, negative na yung acceleration. That is sometimes known as the deceleration. And that only means I am slowing down. Get it? Okay, let's move forward. Let's have another example. And this time, let us calculate the acceleration. This time, the initial velocity is 51 kilometers per hour, or in standard units, 14 meters per second. Let us assume the velocity this time is the same. Kapoy kay control sa accelerator para always 51 ang reading sa speedometer. Okay, let's go. Let us pause and calculate its acceleration. The final velocity is still 51 kilometers per hour or 14 meters per second. And the time elapsed is 34.68 seconds. So acceleration is equal to final velocity minus initial velocity divided by time. So 14 meters per second minus 14 meters per second all over 34.68 seconds. And that will give us 0 meters per second. That is what we call a constant motion. That only means our velocity is always constant. It is not changing. Okay? Very good. Let's have an application. Suppose my motorcycle is moving at 85 kilometers per hour or 24 meters per second. Assuming a constant acceleration of negative 1.2 meters per second squared, how long will it take to bring this motorcycle to a complete stop? Let us manipulate the equation, and that will give us time is equal to velocity final minus the initial velocity divided by the acceleration. That is 0 meters per second minus 24 meters per second divided by negative 1.2 meters per second squared. And that will give us 20 seconds. The 0 there is significant. So, it will take approximately 20 seconds to stop this motorcycle. Sige daw, B, check na to kung tama ba itong calculation. Let's go! Let's have another example. If this motorcycle will accelerate at 1.5 meters per second squared, what will be its speed after 5.8 seconds? Manipulating the original equation gives us velocity final is equal to acceleration times time plus the initial velocity. Acceleration is 1.5 meters per second squared multiplied by 5.8 seconds plus the initial velocity, which is 0 meters per second, and that will give us 8.7 meters per second, or we can convert that into kilometers per hour, and that is 31 kilometers per hour. Okay, let's see if it is 31 kilometers per hour. Let's go! Oh, it's almost 31 kilometers per hour. Okay, let's proceed. Let us assume that we traveled at a constant speed of 41 kilometers per hour or 11 meters per second. What is the distance traveled after the given time, which is 15.44 seconds? Since we are dealing with constant speed, we will use the equation speed is equal to distance divided by time. That means distance is equal to speed times time. And so distance is equal to 11 meters per second times 15.44 seconds. And that gives us 169.84 meters, or using the rules of significant figures, 170 meters. Got it? Let's go! Let's stop here to summarize what we have discussed so far. distance is the total path taken, and that is 10.4 kilometers or 10,400 meters. It is shown in your Google Map. Displacement, on the other hand, is the shortest path from the origin to this point. That is the orange line on the map. Nakita niyo? We will estimate that, and let's say that that is 0.8 kilometers or 800 meters. Estimation rin ako na ha, that is why one significant figure lang. May direction dapat yan kasi nga displacement. So far, the time I took to reach this far is 23 minutes and 38 seconds or 1,418 seconds minus the starting time, which is 19 seconds, and that gives us a total time of 1,399 seconds. Remember, average speed is total distance divided by time. So 10,400 meters divided by 1,399 seconds, and that is 7.4338 meters per second or 7.43 meters per second, or we can convert that into 26.7 kilometers per hour. Whereas our velocity is total displacement divided by time, and that is 800 meters over 1,399 seconds, and that gives us 0.5718 meters per second or 0.6 meters per second, and we can convert that into kilometers per hour, and that is 2 kilometers per hour. Nakuha? Very good. Let's proceed.
Morning ride to the place where you and I were supposed to meet. The city owns the echo on, my thoughts are spinning on and on my head. It seems they lead me back to you. I keep coming back to you. Took a morning ride, found a place up in my mind no one else can see. Maybe it's fate that we lose control. In circles around we go. We become who we ought to know. We just gotta let it go. gotta let it go.